Let's now look at some questions related to linking binomial expansion with partial fractions. The first question is this one. This is from an October-November paper 2005. Question 9. You are going to see that the questions about this, they are very, very similar. At least the three that I picked, they are exactly the same in nature. So the first part just asks you to express a fraction in partial fractions. You should be focusing now in the denominator to see what type of partial fractions we are talking about. This is an order 1 polynomial, this is an order 2, so this is a type 2. And you should know that in order for you to do that, you should break this down into a over the order 1 polynomial plus bx plus c over the order 2 polynomial. I'm just following here the rule for type 2, okay? Now that I've done this, I need to continue following the rule. The next rule says to multiply the whole thing by the denominator that you have over here, the denominator, this denominator over there. The idea is that you eliminate on the left hand side this denominator altogether, just leaving the numerator. And now each one of these fractions is going to eliminate the term that is similar to the denominator of each one of the fractions, leaving the other one. What do I mean with this? If you multiply the whole thing by this, you eliminate the x plus 2, right? They cut out, and you are left with the x squared plus 1. If you do the same thing, multiply the whole thing by that, the numerator is going to cut out the x squared plus 1, leaving just the x plus 2, okay? Next step, you just have to cherry pick the values of x that are capable of eliminating terms. And if you look over here, if x is minus 2, you eliminate all of this altogether. So when x is minus 2, this is just going to be 10. Minus 2 squared, that's 4 plus 1, that's 5a. And this is going to be 0, right? So you know that just by looking at this, a is going to be 2. There is no way with the type 2 fractions to eliminate any more of these letters. So now you just have to substitute what you know, which is the value of a over there, and expand the whole thing. That's all I did over here. I expanded the whole thing, I cross multiply over there, and then I organized things with like terms. So this is the coefficient of x squared, this is the coefficient of x, and then you have 2c plus 2. And now you need to compare what you have on the left-hand side with what you have on the right-hand side. On the left-hand side, you have the term with x squared has coefficient 3. So you have to equal the coefficient that you have on the right-hand side, which is b plus 2, to the value that it actually should have, which is 3. Do the same thing to the others. The term with x on the right-hand side is 2b plus c, but you know that the value of this should be, as you can see here, 1. And there is no term with no x. So you know that 2c plus 2 must be equal to 0. You are left with two unknowns, which are the values of b and c, and you have more than 2 equations, so you can just pick any 2 of these 3. Whichever you pick should give you the same result, b equals 1, c equals minus 2. So now you know all the values. A is 2, b equals 1, c equals minus 1. So this will become this, and it's solved. And now, hence, now that you have the partial fractions, obtain the expansion of this is that, in ascending powers of x up to and including the term in x cubed. Okay, so now that you know, now that you have this complex function broken down into smaller fractions, you can organize these and make visible here the way in which you are going to expand. All right, 2 over x plus 2. In order for you to expand, don't forget what you need. You need something like this. Or to be more specific, you need something like this, because if you get that, you can organize it so you can expand it, remember? All right, so 2 over x plus 2. You can write this as 2 over 2, and then you factorize what you have left. I also put the 2 first, so this is going to be 1 plus x over 2. This 2 is going to cut out with that 2, so this equals what? This equals just 1 plus x over 2 to the power of minus 1. You can expand this. Let's work with that one as well. This is x minus 1 times 1 plus x squared to the power of minus 1. You can expand that too. So let's stop over here. I make here a 2, all right? And let's just expand each one at a time. You need to go up until the term with x cubed according to the question, right? So here you are just applying the rule for binomial expansion. So 1 plus n times the expression plus n times n minus 1 over 2 factorial times the expression square plus n minus n minus n times n minus 1 times n minus 2 over 3 factorial times the expression cubed. Okay? Just take care of this to the algebra, and here you have the 4 terms up until x to the power of 3. The expression is x over 2, so this should be trivial to you right now, means that the range of values for which this expansion is valid is modulus of x smaller than 2, so between minus 2 and 2. Okay? Let's now expand that one. The expression now is x squared, so 1 plus n times the expression plus n times n minus 1 over 2 factorial times the expression square plus n times n minus 1 times n minus 2 divided by 3 factorial times the expression cubed. This is equal to that. Modulus of x squared smaller than 1 is the same as modulus of x smaller than 1, so x is in between minus 1 and 1. Now that we know the expansion, we can pick up where we left. So this is going to be equal to this expansion. I just wrote it. Plus x minus 1 times this expanded, which is this. Now just expand this last bit. And focus that we just need to organize up until the term with x cubed. You have here terms with x to the power of 4, x to the power of 6. Never mind that. Don't waste time. So all of that has terms that goes until x cubed. But then over here, you just need to worry with x times this, x times that. You don't need to worry about x times x to the power of 4. This is already too big. And dealing with the minus 1, you just need to worry about minus 1 times 1, minus 1 times x squared, and then that's it. Minus 1 times minus x squared. Okay, so these are the only parts that I actually worried about. I didn't bother doing more cross multiplications because that would be just a waste of time. Now I just organize this into ascending powers of x, and they asked just until the term with x cubed, and here you have it. This is a structure for every single question, as you're going to see from now on. For the other 2 questions, I'm going quicker because it's the same thing. Question 9 in an October-November 2007, paper 3. You have expressed this in partial fractions. So look over here. This is top 1. All of these terms, they are order 1 polynomial. So you just apply the rule for order 1 polynomials. Where am I? This one. Okay. So you have 3 fractions, a, b, and c, over each one of those. Then multiply the whole thing by the denominator and eliminate the corresponding bits. This is what you'll get. So this one eliminates the 1 minus x, keeping the other two. This one eliminates the 1 plus 2x, keeping the other two. This one eliminates the 2 plus x, keeping the other two. Okay? It's a type 1 is the best one that can happen because you can cherry pick all these values. If you choose x to be minus 2, you eliminate the term in a and in b, leaving just a c, right? If x over here is minus 2 and if x over here is minus 2, all of this is going to be 0. All of this is going to be 0. So minus 2 substituted over here equals 36. Minus 2 substituted over here yields minus 9c, so c is minus 4. Now let's do the substitution of x equals 1. If x equals 1, you eliminate this term and therefore all of that. You eliminate this term and therefore all of that. So minus 8 times 1 squared minus 1 plus 2, that's 9. And then over here, substituting 1 over here will give also 9a, so a equals 1. To eliminate a and c, keeping b, x must be equal to minus 0.5, right? Do the same thing, and you'll get the value of b as being 2. So now you know the values of a, b, and c, so there you have the first part written. Then the next one is hence find blah blah blah, if I'm not mistaken. Hence, okay, now that you know the partial fractions, obtain the expansion of all of that in ascending powers of x up to and including the term with x squared, okay? A little while ago it was x cubed, now is x squared. So what is this? This is just 1 minus x to the power minus 1. This is 2 times 1 plus 2x to the power minus 1. And this is 4 over 2, open brackets, 1 plus x squared to the power minus 1. And 4 over 2 is 2. Okay? Now that you have this very ready to be expanded, just stop it and expand each one of them. I'm not going to explain how to expand. You should know that already. So this is going to yield that. You must stop on x squared. That's all you need to know. Expanding this will give this. Expanding this will give that. What are the range of values for which each one of these can be applied? This is minus 1 and 1. This is minus 1 half, 1 half. This is minus 2, 2. Okay? I don't think I mentioned this a little while ago, but for the overall range of values, you always pick the shortest range, which would be this one. And the previous one, this was, it was this one, okay? I don't think I mentioned a little while ago. Anyway, there it goes. So I already solved that part. Okay, so now that you know the first 3 terms of the expansion, substitute each one of these by these 3 terms. For this one, multiply by the 2. For this one, multiply by the minus 2. Organize and write the first 3 terms up until x squared. See, pretty much the same. And so we'll beat this one. Winter 13, paper 31, question 7. You have the function express f of x in partial fractions. What type is this? This is type 2 as well, right? Order 1, order 2. So it's going to be a over x minus 2 plus bx plus c over x squared plus 3. All right, multiply the whole thing by the denominator of the left-hand side. You are left with the numerator. This eliminates the term with x squared, keeping the x squared plus 3. This eliminates the term with x squared plus 3, keeping the term with x minus 2. It's a type 2, so you can only cherry pick one x, which is going to be 2 over here, eliminating this. Substitute here x by 2, substitute here x by 2. This is what you'll get. You'll find a. In order for you to get b and c, now you need to use the value of a over there. That's what I did. Expand that, organize stuff, and let's compare. Term with x squared. Over here is 2, over here is b minus 1. So b minus 1 equals 2. Term with x. Over here is minus 7, over here is c minus 2b. So c minus 2b equals minus 7. Everything else, minus 3 minus 2c equals minus 1, okay? Again, 3 equations, only 2 unknowns, just pick any 2. Here you have the values. Now that you know the values for a, b, and c, substitute there, and this is what you get. The rest of the question is typical already. Hence, obtain an expansion of f of x in ascending powers of x up to and including the term in x squared. So you just need now to organize this so that you can expand. So this is going to be 3x minus 1 over what? This needs to be a 1 and placed first. So you factorize 3, open brackets, 1 minus x squared over 3. This must be also, this minus 2 must be also a 1. So you put minus 2 times 1 minus x over 2. Okay, this is a denominator, so both of them are to the power of minus 1 over here. This one I just simplified because you have 3x minus 1 over 3, so that's just x minus 1 over 3. And this is minus and minus is plus, so you have just 1/2. Stop here. Let's expand that and that. That's what I did over here. You should be comfortable expanding very quickly. Okay. You know that this yields a value of x that is in between minus 3 and 3. This gives you a value of x that is between minus 2 and 2. All right, so this one is going to win, is the shortest one. I can put it here already. And now that I know the first terms, I have actually here a term that doesn't matter because all I need is up until x squared. So I just need to put those two. So it's x minus 1/3 times these two. Don't bother doing that one. Plus 1/2 of, instead of this, now I'll put these 3. Okay. Now expand the whole thing. Organize stuff. I just want up until x squared. And this is the final result. As you can see, the questions are pretty similar, and they are also similar in terms of the weight it carries. 10 points, 10 points, 10 points.